The recording of the meeting is on now. So we are going to discuss the effect of current and wind. These two very important factors in chart work. Almost in every question of chart work, you will have this concept of current and wind coming in. So the current or the wind will find its way almost in every question of chart work. So this becomes a very important concept for us. Making a mistake in current and wind ensures that whichever questions it is involved in, the questions will become wrong. And many times people have difficulty in allowing for these factors, the current and wind. It is basically considered in two different ways. One is known as allowing for the current and wind. That means you are steering a certain course. The wind is affecting you and the current is affecting you. What is the position where you will arrive? So this is known as allowing for the current. Basically, you are allowing the current and wind to disturb you or to distract you, to push you away from your intended track. The second method in which this current and wind is used is known as counteracting the current and wind. Counteracting the current and wind basically means you know the destination where you have to reach. You know that there is some current in the area, there is some wind in the area, and you have to steer such a course that after the wind and current has affected you, you still reach on your destination. So this is known as counteracting the wind and the current. So go ahead, Inderpreet.
Sorry, sir, by mistake. By mistake.
Okay, no problem. It's okay. So we will see one by one how the current is allowed, how the wind is allowed, and how they are counteracted. We will also understand how do they affect the progress of the ship one by one. We will also discuss what are the terms which are associated with the wind and the current. There are some terms like for current we use set, rate, and drift. And for wind we use the leeway angle, the effective course और the leeway track. So ये सारी terms को हम one by one अभी वीडियो में देखेंगे. So let me set up the video for you and we progress on this current and wind topic.
Welcome to Marine Gurukul video series. In today's video, we shall cover application of wind and current in chart work. Now, before we talk about wind and current,
Beta, is the audio and video both loud and clear?
It is clear, sir.
Yes, sir.
Yes, sir. Yes, sir.
Okay, beta.
let's understand few terms pertaining to types of positions that we obtain and use in our navigation. The first one is fixed or observed position, and this is the position of a ship that is obtained by intersection of two or more position lines, intersection of two or more position circles, intersection of one position line and one position circle. I'm sure you would have watched the earlier videos on position lines and position circles and would by now be comfortable with the concept of PLs and PCs.
Beta, we have not yet covered up position circles. We will be covering it up after this video. So position lines we have already covered up. So we will discuss in detail about how position circles are obtained.
Or a position that is obtained by a reliable electronic navigational aid like GPS, which may provide the position in its coordinates of latitude and longitude. A fixed position or an observed position is a confirmed or validated position. It's represented on the chart with a symbol of a dot and the circle surrounding it. The dot in the center represents the position of the ship. And if we want to indicate the time for which the fix has been marked, it can also be indicated against the symbol, as you can see on your screen out here.
So this is a observed position, also known as a fix. This has been observed by taking a position line, position circle, or by using a instrument electronic navigation like GPS. And the symbol for this, what we use is this one, a circle and a dot in between with the time written along with it. Go ahead, beta.
Yes, sir. ये आपकी सारी स्टेटमेंट तो वैलिड हो रही है, पर ये जब आपने लिखा है इंटरसेक्शन ऑफ वन पीयर लाइन एंड पोजीशन सर्कल, जब हम ये स्टेटमेंट हम कॉन्टूर पीएल और पोजीशन सर्कल पे लाएंगे, वहां पे वैलिड हो पाएगी सर?
Which one, beta? Intersection of two or more PLs?
Third one, sir. Intersection of one PL and one position circle.
Yes, beta, it will be applicable with a depth contour also. If you have a depth contour and a position circle, they will intersect at two particular points, and out of two, one will be our position. Okay, beta, got it?
So जैसे normally हम one position line और position circle में we can verify by applying cos and जो भी हमें other values भी were given, but इसमें तो PL तो पूरी curved या एक straight line में यहाँ पे वो applicable हो सकता है.
Right, बेटा आपकी आवाज बहुत broken आ रही है. I was barely able to make anything, but we will do these questions, beta. Then it will become clear to you. Don't worry.
Okay.
Okay, let's continue then.
The next one is DR position or the dead reckoning position, which is obtained by factoring in only the ship's displacement caused because of the course she steered and the engine distance that she has covered from a last known fix. So to mark the DR of the vessel, we must know the last known fix. We must know the course or courses steered during that interval since the last known fix and the engine distance that has been covered. DR position on the chart is represented by a cross. And if the time has to be represented for the DR, it can also be marked next to the symbol. DR position does not factor in effect of any external force like current or wind experienced by the ship.
So this is also clear, beta, the DR position. Okay, great. So let's continue then.
The next is estimated position. It is the position obtained by factoring in ship's displacement because of the course steered, engine distance covered, together with the estimated current and or wind that may have been experienced by the vessel during that interval. EP on the chart is marked with a triangle or a square with a dot in the center. And if the time has to be indicated, that can also be mentioned against the symbol. EP factors in the estimated effect of current and wind experienced by the vessel. So now amongst all these, undoubtedly, an observed position or the fix of the vessel is the actual position of the vessel that has been observed by definitive position fixing means. Next in the order of accuracy would be the estimated position, and last would be the DR position.
So these are the three types of positions which we have. As we just now saw, the best position to consider would be a observed position or a fix, because that has been actually observed either by visual observations or by using an instrument. The next most accurate position after fix would be the EP, the estimated position, because EP considers the effect of current and the effect of wind, which is pushing our ship or disturbing our ship to move in a particular direction. The least accurate of the position would be the DR position, because DR position does not factor in the current or the wind. It only considers or factors in the engine speed and the engine distance, the course steered by the ship.
We shall be using these positions depending on the information that is available in the same order of accuracy. If we have a choice, fix would be of the first topmost priority, followed by EP, and if none of them are available, we would use the DR position. Now let's understand the effect of current on the ship's track. What is current? Current is a continuous directed flow or movement of seawater because of varied causes like difference in temperature, difference in salinity, etc., etc. Moving seawater causes the displacement of objects floating in it as it carries them along. So the floating objects, which are freely floating in water, would be carried with the water as the water flows because of the current. In the absence of any external factor like current, the ship's track or displacement over the ground shall be same as its displacement through water. So we must understand the difference between track through water and track over the ground.
So all clear up to here, beta? Any doubt in the mind?
So can you open up the last? Yes, this one. I was noting it.
Okay. Let me know once you are done, beta.
Yes, sir. Thank you.
Done. Can we move ahead, beta?
Yes, sir. Thank you.
Okay.
We can go ahead.
Okay.
So we must understand the difference between track through water and track over the ground. Now, let's understand this thing through the simple illustration. We have a vessel which is at position A at 0800 hours. It steers a course of 070 degrees true at an engine speed of 11 knots. There is no wind, no current, and we need to plot and obtain the DR of the vessel and the fix of the vessel at 1000 hours. So we plot the 0800 hours fix on the chart, as you can see. Now, from the last known fix, which is 0800 hours, if we apply the ship's displacement vector because of her own propulsion, that is the CTS and the engine distance, that shall give us the DR, as we have already discussed under the DR explanation. So from A, we draw the CTS of 070 degrees true. In chart work, the CTS is always marked with single arrow, and you please have to respect this convention of single arrow to represent the CTS line. On this CTS line from A, if we mark off engine distance for 2 hours, which shall be 11 into 2, that is 22 miles, we get point B. Point B is obviously the DR at 1000 hours. Now, as there is no other displacement vector acting on the ship than her own propulsion, obviously her track over the ground would be same as the track through water. What we have plotted is the track through water, and in this case, the track over the ground shall also be the same. So actually the vessel would be at point B at 1000 hours. So this track over the ground is represented in chart work by course made good and distance made good. And this particular vector is represented by two arrows. You can see the two red arrows coming on the same track. That means track A to B, besides being a CTS track or track through water, is also a course made good track and track over ground.
Okay, so you see beta, in this case, we had a very simple condition. There was no current in the area and there was no wind in the area. Vessel started from point A, steered a particular course with a particular speed and reached point B. So this AB is our CTS vector, that is course to steer vector. If you remember, I had shown you the symbols that a CTS course to steer vector is represented by a single arrow. That's why you see a single arrow being marked here. Since there is no current and no wind, this is also our course made good. That is our course over ground, one and the same thing. And the course made good is marked or represented by double arrows. So you see the double arrows also plotted on the same vector. This vector is both the CTS vector as well as the CMG vector, because in this case CTS, CMG, engine distance and the distance made good or distance over ground are exactly the same. Point B is our DR position also. Point B is our fix also. So there is no wind and current. Any doubt up to here, beta?
No, sir.
Okay, great. Let's proceed ahead.
No, sir.
Very good.
So in this particular case, CMG is same as CTS, DMG, distance made good, is same as engine distance, and this position B happens to be the also fix of the vessel at 1000 hours. So position B is both DR as well as fix. Then we have track through water, which is represented by CTS and engine distance. And we have track over the ground represented by CMG and DMG, though both have been same in this particular case. Now, before we discuss the effect of current, we need to understand the terms that are used to describe current. The direction of the current is represented by what is called as set. Set is the direction in which the water flows. That is, if we say the current is setting south or current is setting 180 degrees true, that means the water is flowing from north to south. The rate of current is the speed of current. It is expressed in knots. The drift of the current is the distance through which a freely floating object at rest relative to sea water be drifted in a given period of time because of the current. Obviously, the drift, if we have to obtain in a certain period, it shall be equal to rate of the current in knots multiplied by time in hours, and what will get drift shall be in nautical miles. Now,
this is also clear, beta, up to here. What is the set of the current, rate of the current, and drift of the current? Okay, great. Let's proceed ahead.
With these terms having been discussed, Let us look at effect of current on the ship's track. When the vessel steams, vessel experiences the displacement vector because of her propulsion, and this displacement vector because of her propulsion acts both through water as well as over the ground. And this displacement vector is represented by course to steer as its direction and engine distance as its magnitude. If this vector is applied to the last known fix, we have already discussed this, it shall give us the vessel's DR at the end of the steaming period. If the ship also experiences current, an additional force vector is caused, represented by set and drift during the interval. This additional force vector, because of the current, causes displacement only with respect to ground or over the ground and not through water, because the water and ship, they float together or drift together because of the current, and so there is no displacement of the ship in relation to water caused by the current. Thus, ship experiences two displacement vectors over the ground. Its track over the ground shall in such cases be along the resultant of the two vectors.
So beta, any doubt up to here? Just have a good look at the slide. Let me know if you have any doubts.
Sir, एक बार ये वाली slide please.
You want to go to the previous slide or this one? You want me to hold on?
Sir, ये वाला थोड़ा explain कर दो ये वाली slide.
Okay, इसमें क्या चीज clear नहीं है बेटा? Can you tell me one point?
Sir, starting से एक बार बता दो please.
Okay, you just want me to repeat it?
Yes, sir.
Okay, all right.
Current on the ship's track. When the vessel steams, vessel experiences the displacement vector because of her propulsion, and this displacement vector because of her propulsion acts both through water as well as over the ground. And this displacement vector is represented by course to steer as its direction and engine distance as its magnitude.
This is clear, beta, the first point?
Yes, sir.
Okay, let's move on to the second one.
If this vector is applied to the last known fix, we have already discussed this, it shall give us the vessel's DR at the end of the steaming period.
Number 2 point is also clear, beta?
Yes, sir.
Okay.
If the ship also experiences current, an additional force vector is caused, represented by set and drift during the interval.
The third point is also clear, beta. This is the effect of the current.
Yes, sir.
This additional force vector, because of the current, causes displacement only with respect to ground or over the ground and not through water, because the water and ship, they float together or drift together because of the current, and so there is no displacement of the ship in relation to water caused by the current. Thus, ship experiences two displacement vectors over the ground. Its track over the ground shall in such cases be along the resultant of the two vectors.
Okay, basically, beta, you see there are two forces acting on our ship. One is generated by its own engines, the engine of the ship. So that is known as the CTS vector, course to steer and engine distance. The second force which is acting on the ship is the current. The current also acts on the ship. and takes it in that direction wherever it is going. Now the ship will move in a direction which is the resultant of both these forces. School time में बेटा +1 +2 में we had discussed about vector quantities. Vector quantities are basically the quantities which have magnitude as well as direction. In this case जो ये current है और जो CTS है ये दोनों vector quantities हैं. इनकी direction भी है. The direction of the CTS is the course which we are steering. The magnitude of the CTS vector is the engine distance. The direction of the current vector is the set. And the magnitude of the current vector is the drift. So ये दोनों vector quantities या vector forces हमारे ship के ऊपर act कर रही हैं and the vessel has to move in their resultant direction. So chart work में we combine these two vectors and find their resultant. कैसे find करते हैं वो हम अभी देखेंगे. So it is basically using the concept of vector addition. So we make a triangle. We will be just making it now on the chart and we will be combining these two vectors to find their resultant. So is it clear now, beta?
Yes, sir.
Okay, all right. Let's proceed ahead.
Let's try to see what we have just discussed through a simple example. We have a vessel at position A at 0800 hours. You can see on your charts. It steers a course of 070 degrees true at an engine speed of 11 knots. The vessel experienced current setting south at 3.8 knots. Now, by plotting, we need to obtain DR and fix. We have already seen in one of the earlier examples, wherein there was no current or wind, the DR and fix at 1000 hours happen to be same. Let's see what happens in this particular case. Now, through A, if we plot our ship's displacement because of our propulsion, then that will be CTS drawn through A, represented by single vector, distance marked off for 2 hours 22 miles. Position B, this becomes the DR of the vessel at 1000 hours. This we have already discussed earlier as well.
Okay, so up to here is clear, beta. A was our initial position. We have just marked our course steered and engine distance on it. So you can see the CTS vector on the chart now.
Yes, sir.
Okay, this is one of the forces which is acting on the ship. The second force is the current.
Yes, sir.
Now to see how does the current affect the vessel's displacement over the ground, for one time at least, let us split this into two distinct parts. Two displacement vectors, one because of ship's propulsion, other because of current, acting simultaneously, but let's assume they act one at a time, each acting for their respective 2 hours. So if only the ship's propulsion vector, CTS and engine distance vector acts for 2 hours, then the vessel is expected to shift from or displace from position A to position B. So at 10 o'clock, you would expect the ship to be at B. Now, once at B, let us assume the engines are stopped. Ship is in complete rest in relation to the seawater, surrounding seawater. And now the current sets in, setting south at 3.8 knots. Now, as the water starts flowing southwards, the vessel would also drift southwards. So the vessel shall start drifting with over the ground in this direction as represented by the green vector. Now the green vector represented by 3 arrows is the current vector, and this is the standard 3 arrow notation that is used in chart work. If the vessel drifts for 2 hours, then she would have drifted through a distance of 3.8 into 2 equal to 7.6 miles, and she would reach point C.
Okay, so this is also clear, beta. At point Bravo, we have applied the current vector, which is basically the set and drift of the current for 2 hours. So that is where we require our position after 2 hours from 8 o'clock. So any doubts up to here, beta? Okay, great. Let's proceed ahead.
Now that means 2 hours of propulsion vector, 2 hours of current vector, both acting for 2 hours each. We expect the ship to reach point C. So C would be the position of the ship at the end of 4 hours in which both vectors have acted one by one. In our case, both these vectors are acting simultaneously. So both are acting for 2 hours each, but not one at a time, but simultaneously. So the effect would still be the same. And at the end of 2 hours, with both vectors acting simultaneously, the vessel would be expected to be at C. That means from 8 o'clock to 10 o'clock, so C becomes my fix at 1000 hours. From 8 o'clock to 1000 hours, the track over the ground would be represented by line AC. This track over the ground we refer to as course made good as its direction and distance made good as its magnitude. It's represented by 2 arrows. So now in chart work, the CTS vector is represented by 1 arrow, current vector is represented by 3 arrows, and course made good vector is represented by 2 arrows. Now, the direction from A to C becomes course made good, which in this case is 091 degrees true, and the distance or magnitude of AC is 20.6, which is the distance made good. Since this 20.6 miles is the distance made good in 2 hours, so the speed made good would be 10.3 knots. So now please remember in this case that each side of this triangle is for the same duration. Here the engine distance was for 2 hours, drift was for 2 hours. So obviously this DMG would also be for 2 hours. So C is the fix at 1000 hours, B is the DR at 1000 hours, and the vessel's position will shift along the line AC, but her CTS does not change. CTS remains 070 degrees. So you see when the vessel reaches here, her heading is aligned in this direction, that is 070, but her position is shifting along this CMG line. When she reaches here, everywhere the heading is same as 070, but position is shifting along the CMG line.
Okay, so just have a good look at the diagram, beta. Let me know if there are any doubts. All clear, beta? No doubts? Okay, very good. So this triangle which you see right now on the screen is also known as course, distance, and current vector triangle. So one side of it, the blue color side you see is the course to steer vector, that is CTS, course steered, and engine distance. The green color side of the triangle, Bravo to Charlie BC side, is the current vector, and it represents the set and drift of the current. And the third side which you see here, the red color side, is the course made good vector. The direction is the course made good and the magnitude is the distance made good by the ship. All the three sides are for exactly the same duration. They should always be of the same duration. So in this case, the duration is 2 hours. Many a times in chart work question, we make a duration of 1 hour. It's known as a 1 hour triangle. Important thing to understand is that the vessel will actually be moving on the red color line, the AC Alpha Charlie line, but will be heading in the direction of AB. That is, the heading of the ship will be in the direction of the blue color vector. The movement of the ship will be in the direction of the red color vector. Course made good represented by 2 arrows. Current is represented by 3 arrows, and CTS is represented by a single arrow. So shall we proceed ahead, beta, if it is all clear?
Yes, sir.
Okay, very good.
Now, let us look at a possibly different scenario. The vessel is at position A at 0800 hours. She needs to reach position C at 1000 hours. Position C is her destination position, could be anchorage, pilot, boarding ground. Now, that means the vessel needs to make a track over the ground, which is represented by AC in 2 hours. So AC would represent the course that the vessel will have to make good and the distance that the vessel has to make good in 2 hours. Since A and C are the same points as in the previous discussion, therefore CMG that has to be done by the vessel is 091 degrees true, and the DMG is 20.6 nautical miles.
So now the question is slightly changed, beta. In the previous question, we were steering a particular course. We were having some current affecting us, and we wanted to find our final position. In this question now, there is a slight change. We know that we have to reach at our destination, which is at point C. So our final position is fixed. Our initial position is also known to us, that is position A at 8 o'clock. So initial position, the final position, they are all fixed up. So which basically means our red color vector, the course made good and distance made good vector is fixed. It is known to us. And now we need to find out the CTS, what course we should be steering so that we reach at our intended position. So that's the change in the question. Just give me 1 minute, I'll unpause.
The current experienced by the vessel is same as in the previous case, that is setting south at 3.8 knots. The master wishes to know what course should the vessel set from A and what engine speed she should be doing so that in 2 hours she is able to reach her destination at point C. So basically, everything is same. So we could consider this in the reverse order to what we had earlier done. Now, vessel wants to reach from A to C, highlighted by this black line, and this is your track over the ground, or the CMG and the DMG vector represented by 2 arrows. Now she experiences current setting south at 3.8 knots. So if we have to reproduce this triangle, that means I'll have to draw the current north of C. Though the set given in the question is south, but what we'll have to do is current, if we have to draw at C, we draw it in the opposite direction, highlighted by this black line now, and represented by 3 arrows pointing southwards as before. So now this is the CMG DMG vector. This is the current vector. Each of them is for 2 hours. Obviously, then A to B vector would be the CTS and engine distance vector. And we get CTS of 070 degrees true, and engine distance of 22 miles in 2 hours. That means engine speed of 11 knots. Now, there is nothing wrong with this working mathematically. It's perfectly in order. But in chart work, we do not, I repeat, we do not reverse the direction of current. So if it was setting south, we would prefer to draw the current setting south only. And to achieve that, we change the point of application of current. So we apply current instead of C, we apply current at A, like this. At A, we have applied current for 2 hours, setting south, and drift of 7.6 miles. This gives us a point D. Now, if we join point D to C, as you can see, what we see here is that A, B, C, D is a parallelogram. Obviously, then A, B, and DC are parallel to each other and also equal in magnitude. So obviously, since it's a parallelogram, therefore, D to C represents the CTS, and D to C distance represents engine distance in 2 hours. So the CTS is 070 degrees true, engine distance is 22 miles in 2 hours, giving us a engine speed of 11 knots. So in chart work, if we have CMG and we have to get the CTS, we would draw the current at the starting point of the CMG line and draw the triangle as the lower part of the parallelogram represents.
Okay, so beta, is it clear up to here? Any doubts or queries coming in your mind?
सर ये जो इनिशियल पॉइंट पे लगाया है कोर्स, इसका रीजन क्या है सर? ये क्या फाइंड आउट करने के लिए है?
ओके, देखो बेटा, मैथमेटिकली तो जो ब्लैक कलर वाली ट्रायंगल थी वो भी सही है, बट चार्ट वर्क में हम करंट को रिवर्स डायरेक्शन में नहीं लगाते हैं, क्योंकि अगर हम ब्लैक वाली ट्रायंगल बनाएंगे, सी वी विल हैव टू अप्लाई द करंट इन द रिवर्स डायरेक्शन. पॉइंट सी से हमें नॉर्थ डायरेक्शन में करंट को लगाना पड़ेगा. द करंट इज एक्चुअली सेटिंग साउथ, so we avoid this in chart work. So to apply the current in the south direction, हम लोग क्या करते हैं, हम करंट को A पॉइंट पे अप्लाई करते हैं, इनिशियल पोजीशन पे अप्लाई करते हैं. So once we apply it on A, it is applied in the same direction in which the current is going. Okay beta, is it clear?
Okay sir, got it.
सर एक डाउट है सर, इसका कोई रीजन है क्या कि हम ऑपोजिट डायरेक्शन में अप्लाई नहीं करते?
रीज़न कोई नहीं है बेटा. एज आई टोल्ड यू, मैथमेटिकली आप इसे रिवर्स डायरेक्शन में भी अप्लाई कर सकते हो, बट टू द माइंड इट मे लुक लिटिल ऑड कि भाई करंट तो साउथ सेट कर रहा है और आप इसे नॉर्थ डायरेक्शन में लगा रहे हो. सो इट मे गिव राइज टू ए कंफ्यूजन इन योर माइंड सम टाइम. दैट इज़ द ओनली रीज़न. देयर इज़ नो अदर रीज़न. मैथमेटिकली दोनों की दोनों ट्राइंगल्स सही हैं. अगर आप ब्लैक ट्रायंगल भी बनाओगे ऊपर वाली, तो मैथमेटिकली तो वो भी सही है, बट जस्ट टू अवॉइड द कंफ्यूजन एंड हैव और अप्लाई द करंट इन द सेम डायरेक्शन इन विच इट इज़ गोइंग और सेटिंग, हम नीचे वाली ट्रायंगल को यूज़ करते हैं व्हेनेवर वी आर काउंटरएक्टिंग द करंट.
सर जैसे हमने अगर ऑपोजिट साइड में ड्रॉ कर दिया एंड वी राइट इट डाउन एट द साइड, as we know we already aware of CMG, to find out CTS we applied the current in opposite direction. So in that way examiner will correct this question or he will कुछ भी कर सकता है?
Beta, up to the examiner. If I am the examiner, maybe I will not deduct any marks, but if somebody else is the examiner, then I don't know. Okay. Some people may take it otherwise beta. Some of the examiners, they may say, अरे इसने current को opposite direction में क्यों लगाया है? So he may deduct some marks even though it's mathematically correct. So it is better to follow the bottom triangle for counteracting. Okay, beta, got it?
Yes, sir.
Okay. So everything looks clear up to here, beta. There is no doubt, no confusion in your mind. This is a very important concept.
सर एक चीज और है सर.
हाँ, बोलो बेटा.
सर जैसे अभी इसमें हमें सिर्फ CTS और इंजन स्पीड के लिए हमने नीचे वाला ट्रायंगल बनाया. अगर हमें इसमें DR पोजीशन निकालने के लिए बोला होता तो हम ऊपर वाले ही बनाते ना.
If they would have asked us only to find the DR position, right?
Yes, only to find us the DR position by giving the course made good DMG and set and drift.
Yeah, that's एक minute. You are saying that they have given us the course made good, the distance made good, and they want us to find the DR position. Correct, beta?
Correct, sir. Same question में find the CTS and ES की जगह DR position. Find the DR position होना चाहिए तो ऊपर वाला ट्रायंगल बनेगा ना.
Okay. वैसे ये बहुत अनरियलिस्टिक क्वेश्चन है, बट यस, अगर ऐसा क्वेश्चन डाला जाए, वो हमसे पूछें कि DR पोजीशन बताइए, then in that case you will have to draw the black color AB vector, alpha to Bravo vector, and B would give you the DR position.
Okay, sir.
सर अगर कोर्समेट को दिया हुआ है तो हम करंट को काउंटर करेंगे एंड सीटीएस है तो अलाउ करेंगे.
Yes, that's right, beta. Very good. So if the course to steer is given to you, we will be allowing for the current, and if the course made good is given to you, we will be counteracting the current.
So basically तो सब कुछ एरो पे डिपेंड करता है ना. जैसे हम एरो मार्किंग करते हैं, अगर हम ऊपर वाले में भी सही एरो मार्किंग सही कर रहे हैं तो ऊपर वाला भी सही है.
Can you explain little bit, beta?
सर जैसे हमने CMG DMG में टू एरो मार्किंग करी है, अगर वो जैसे हम सेट एंड ड्रिफ्ट में 3 एरो मार्किंग कर रहे हैं और वो एरो मार्किंग हम ऊपर की जगह कर देंगे नीचे की जगह के अलावा, ये ब्लैक वाले ट्रायंगल में अपवर्ड्स कर देंगे डाउनवर्ड की जगह, तो वो गलत हो ही जाएगा. अगर हम डाउनवर्ड कर रहे हैं ब्लैक ट्रायंगल बना के भी तो तब भी अंडरस्टूड है ना सर.
Yeah, that's right, beta.
हाँ
Basically,
एरो रिप्रेजेंट कर रहा है डायरेक्शन को.
yeah,
सर
that's right.
ऐसे शुभम ने जो पूछा सर वो कोर्समेट गुड की कंडीशन पे पूछा है. तो कोर्समेट गुड की कंडीशन में सर ऊपर वाला ट्रायंगल कैसे एप्लीकेबल होगा, बिकॉज वी हैव टू कॉन्ट्रैक्ट करंट. अगर करंट दिया हुआ है तो नीचे वाला
बेटा,
ट्रायंगल आएगा ना.
अगर कोर्स मेड गुड हमें दिया होगा तो हम नीचे वाला ट्रायंगल ही बनाएंगे, और अगर हमें CTS दिया होगा तो हम ऊपर वाला ट्रायंगल, ब्लैक कलर वाला ट्रायंगल बनाएंगे. दैट्स व्हाट वी विल डू प्रैक्टिकली. एंड टू गिव यू ए लिटिल मोर इंसाइट इनटू दिस ट्रायंगल, अगर आप इस ट्रायंगल में ध्यान से देखो तो इस ट्रायंगल में हम लोग CTS और करंट वेक्टर को एक ही डायरेक्शन में अप्लाई करते हैं, और जो CMG है वो ऑटोमेटिकली ऑपोजिट डायरेक्शन में आ जाता है. लाइक अगर आप ब्लैक कलर की ट्रायंगल में देखो, द CTS एंड द करंट, दे आर मूविंग इन ए क्लॉकवाइज डायरेक्शन फ्रॉम पोजीशन A to B to C. इट्स मूविंग इन ए क्लॉकवाइज डायरेक्शन. और अगर आप CMG को देखो, इट मूव्स इन द ऑपोजिट डायरेक्शन, दैट्स एंटी क्लॉकवाइज. सो ये एक बेसिक कॉन्सेप्ट है वेक्टर एडिशन का. ओके, बट यू डोंट नीड टू बॉदर अबाउट इट. इट विल ऑटोमेटिकली बी टेकन केयर ऑफ वंस यू आर क्लियर अबाउट कि आपने करंट को बाद में लगाना है या पहले लगाना है. सो इन केस ऑफ CTS बीइंग गिवन टू अस, हम करंट को बाद में अप्लाई करेंगे, CTS पहले लगेगा. इन केस ऑफ CMG गिवन टू अस, हम करंट को पहले अप्लाई करेंगे and CTS will be found later on. आपने बस एक ही चीज़ को अपने माइंड में याद रखना है, जब भी कभी हमें कोर्स स्टीयर्ड दिया हुआ है तो हम करंट को बाद में लगाएंगे, पहले CTS फिर करंट. और जब भी हमें CTS को फाइंड आउट करना है और कोर्स मेड गुड दिया हुआ है तो हम करंट को पहले अप्लाई करेंगे. Okay, beta, clear up to here? Okay, all right. So if you want, you can just take a screenshot just to have a look at it when you are comfortably sitting at home in the evening. And next lecture में मैं एक बार दोबारा इसको discuss करूँगा. If you want, we can make this triangle once again. And थोड़ी सी इसमें अभी और कुछ एक चीज़ें बाकी हैं. So we will continue our discussion on this course speed and current vector triangle. So I will give it a break for now. We are almost going to finish our second session. Okay, so that was a very important concept of current. We have not yet involved the wind. So next time when we meet in our next lecture, we will revise this current triangle and we will also introduce the effect of wind. So that's the end of the session from my side. So anything from your side?
Nice. Thank you, sir.
Okay, beta. So see you in the next class then. Till then, bye bye.
Thank you, sir. Have a good day.
Thank you, sir.
Thank you. Bye bye. Thanks.